Good day. This video discusses Introduction to Control Systems. Control System. A control system is a system which provides the desired response by controlling the output. The following figure shows the simple block diagram of a control system. Here, the control system is represented by a single block. Since the output is controlled by varying input, the control system got this name. Examples of control systems are traffic light control system and washing machine. For the traffic lights control system, a sequence of input signal is applied to this control system, and the output is one of the three lights that will be on for some duration of time. During this time, the other two lights will be off. Based on the traffic study at a particular junction, the on and off times of the lights can be determined. Accordingly, the input signal controls the output. So the traffic lights control system operates on time basis. Based on some parameters, we can classify the control systems into the following ways. First, a control system is either continuous time or discrete time. In continuous time control systems, all the signal are continuous in time. But in discrete time control systems, there exists one or more discrete time signals. Another classification is a control system may either be seesaw or MIMO control systems. Seesaw is short for single input and single output control system. For this control system, there can only be one input and consequentially only one output. On the other hand, MIMO is short for multiple inputs and multiple outputs control system. Now for this control system, there can be more than one input and of course, there will be more than one output. Control system can also be classified as either open-loop control systems or closed-loop control systems. This is based on their feedback path. Let's take a look at this in more detail. Open-loop systems. In open-loop control systems, the output is not fed back to the input, so the control action is independent of the desired output. The following figure shows the block diagram of an open-loop control system. Here, an input is applied to a controller and it produces an actuating signal or controlling signal. The signal is given as an input to a plant or process which is to be controlled. So the plant process produces an output which is controlled. The traffic light control system, which we discussed earlier, is an example of an open-loop control system. Closed-loop control systems. In closed-loop control systems, output is fed back to the input, so the control action is dependent on the desired output. The following figure shows a block diagram of negative feedback closed-loop control system. The error detector produces an error signal, which is the difference between the input and the feedback signal. This feedback signal is obtained from the block feedback elements by considering the output of the overall system as an input to this block. Instead of the direct input, the error signal is applied as an input to a controller. So the controller produces an actuating signal which controls the plant. In this combination, the output of the control system is adjusted automatically until we get the desired response. Hence, the closed-loop control system are also called the automatic control systems. Traffic lights control system having sensor at the input is an example of a closed-loop control system. To summarize the differences between the open-loop and closed-loop control systems, you may see this table. For open-loop control systems, control action is independent of the desired output since it has no feedback, so feedback is not present. These are also called non-feedback control systems. Now, the advantage of this is it's easy to design and these are economical. But of course, it is inaccurate. Now, closed loop control systems, control action is dependent of the desired output because of the feedback, so feedback path is present. These are also called feedback control systems. The disadvantage is that it's difficult to design and a little costlier than the open loop control system. But in turn, it is more accurate.